All right, guys, so here's the deal for the exploration coming up in class soon. It's called Coffee Stop. And by the way, this is a screenshot of what you get when you type in coffee in the East Village on Google Maps. It's like, oh my God, so many coffee shops. People got to get their coffee. I don't know. Anywho, so the scene. Here's the scene. Dave is going to meet his buddy Eric for coffee. But of course, in his infinite busyness, Dave forgot exactly where the coffee shop is. But he knows it's on First Avenue, somewhere between Houston Street, which we're going to kind of call 0th Street, and 20th Street. So what he decides to do is, listen, he's going to walk to First Avenue, somewhere in that range on First Avenue, and then he's going to text Eric. When Eric texts him back, Dave will then walk at a constant speed of 1 block per minute to the coffee shop. So here's the challenge. On a set of axes, we're going to graph something. Suppose that Dave doesn't know this, but the coffee shop is on 8th Street. So, right, Dave goes to First Avenue, he texts Eric, Eric texts back, the coffee shop is on 8th Street. And so depending on where Dave is, right, if Dave is right on 8th Street, he's already there, but if Dave is far away, it's going to take him a little while to get there. Depending on where Dave is on First Avenue, right, he's somewhere between 0th Street and 20th Street, it's going to take him different amounts of time to get to the coffee shop. So what I'd like you to do is to create a graph that shows the relationship between what street Dave is on and how many minutes it's going to take him to walk to the coffee shop. So for instance, and I would suggest you might as well do this on Desmos. So I've labeled the axes, by the way, to do that. You can click on this graph settings, and on the x-axis you can write down what you'd like it to be called, street, minutes to travel, minutes to travel. So for instance, we know that the coffee shop is on 8th Street, right? We're going to say that the coffee shop is, I don't know, First Avenue and 8th Street. It's somewhere in there. All right, so for instance, I'll give you a little bit to start with, and then you're going to do the rest, right? So suppose that Dave was on 8th Street to begin with, right? Then it'll definitely take him 0 minutes to get there because he's already there. So boom, there's 1 point on our graph. Suppose that Dave was on 9th Street when he got that text message, right? We know he walks 1 block a minute. So if he's on 9th Street, it's going to take him 1 minute to walk to 8th Street to get to the coffee shop. All right, so it'll take him 1 minute. Okay, so that's another point that's going to be on this graph. That's it. That's all I'm going to give you right now. And then I just want to tell you about some extensions challenges associated with this assignment. So if you can figure that out, some extra challenges. So what if the coffee shop were actually on 15th Street? The question is, how would that change your graph compared to if the coffee shop were on 8th Street or some other street? Now let's think about the original problem again, coffee shop on 8th Street. What if it were now the case that Dave was, a fast, aggressive New York City walker? We all see him all the time. Anyway, suppose that he could walk 2 blocks every minute. Not 1 block every minute, but 2 blocks every minute. So twice as fast. What would that do to the graph, right? You have your original graph from before when he walks 1 block a minute. What if he walks 2 blocks a minute? What if he had recently sprained an ankle and walked really slowly, only half a block a minute? How would that change the graph? And last but not least, see if you can come up with an equation to describe all those graphs that you created. So those are the challenges to extend beyond the normal assignment. And with that, best of luck.